I'm lost, completely lost. My JavaScript code is running, the computer knows what it's doing, but I have no idea where we are right now. Ever written a function that calls another function, that calls a third function, and suddenly your console throws a massive red error and you're staring at it like it's alien hieroglyphics? Don't panic. Today, we are unlocking JavaScript's internal GPS, the execution context, and the call stack. Once you understand these two concepts, you'll go from blindly writing code to reading JavaScript like a map. Let's dive in. First up, execution context. Sounds fancy, right? It's basically a scary name for a very cozy concept. Imagine you're throwing a huge house party. You've got two types of spaces. The main living room, global execution context. This room gets built the exact millisecond your JavaScript file loads. There's only one global room and anyone in the house can hang out here. The private VIP lounge, function execution context. Every time you call a function, JavaScript creates a brand new custom VIP lounge just for that function. It gets its own variables, its own rules, and when the function is done, poof, the lounge gets demolished. It's like a pop-up party room that self-destructs when the music stops. So JavaScript creates all these VIP rooms, but how does it remember which room it's currently in and where to go back to when a function finishes? Enter the call stack. The call stack works on a LIFO principle: last in, first out. Think of a tube of Pringles. The last chip you put in top of the tube is the first chip you eat. You can't eat the bottom chip without going through the top ones first, unless you break the physics of the snacks. And if you try to stuff too many functions into the stack at once, you get every developer's favorite nightmare: maximum call stack size exceeded. Yep, that's literally where the website Stack Overflow gets its name. when a recursive function loops infinitely and explodes the stack. Let's go to the code editor, and this is our global execution context. And I would like to add 3 functions. First, multiply, which takes 2 parameters and simply returns a times b. Next, a square function, which takes a number and returns, here I want to use the multiply function. Multiply, and I pass number as the arguments. Finally, a third function, print square, which takes a number, and first, using the square function, we store that number in this result constant, and finally console.log, and here I use string interpolation, n squared is, and then the result. As the last step, I simply call print square, and let's pass 5 as the argument. I save this. Here you see that this print a square function, our third function, is calling our second function square, and our second function is calling multiply, which is the first function. Okay, so let's run it. I click on inspect and the console tab. Here you see the result. 5 squared is 25. If I change it to, for example, 8, and save it one more time, now you see that 8 squared is 64 is printed in the console. So it's working, but I want to show you something else. Alright, let's stop talking about this in theory and actually watch it happen. I've got 3 functions here. Multiply takes 2 numbers and multiplies them. A square calls multiply to a square a number, and print a square calls a square and logs the result. Nothing fancy, but watching how JavaScript actually runs this is where it gets interesting. I've dropped the debugger statement inside print a square. That's going to pause execution right when we hit it, so I don't have to scramble clicking line numbers while we talk. Let's run it, and there we go. We're paused. Look at the call stack panel over here. Right now it says print a square, and below that anonymous. That's our global context, the one that exists from the moment the script starts. So right now the stack has 2 things on it, global at the bottom, print a square on top. Now watch what happens when I step into this next line, where we call a square n. New entry. A square just got pushed on top. Stack's now 3 deep. Global, print a square, a square. Let's go one level further. Step into multiply. And there's our 4th. Multiply is now on top. This is as deep as we go. 4 contexts stacked up, each one waiting on the one above it to finish. This is the whole idea. Nothing gets removed from this stack until the functions on top of it is completely done and has returned a value. Watch, I'm stepping out of multiply now. Gone. Multiply finished, returned its value back to a square and got popped right off the stack. We're back down to 3. Same thing happens with a square. Popped, back to 2. Just print a square and global. And once print a square finishes logging our result, it pops 2. And we're back to just the global context, like nothing ever happened. That's it. That's the call stack. Every function call pushed on top, every function that finishes pops right back off. Now what happens if something never gets popped off? Let's write a function that calls itself with no way to stop. Here I comment out these lines and write a function, go deeper, which takes a number, and first prints that level and then the number, and then I call that one more time, but this time I increment that argument here. Okay, and finally let's call it passing 1. Cool, I save this and look at this. And there it is. Range error, maximum call stack size exceeded. That's not JavaScript being dramatic. That's the stack literally running out of room. Every call added another frame and none of them ever got to finish and pop off, until there was nowhere left to put them. So to recap your new superpower: execution context, where variables and code live, call stack, how JavaScript keeps track of function execution order. Pro tip: next time you see a massive error stack trace, read it from top to bottom. The top line is where the error actually happened. If this video finally made the call stack click for you, drop a pancakes emoji in the comments so I know you made it to the end. Hit that like button, subscribe for more bite-sized JavaScript tutorials, and check out my video on JavaScript's scope right over here. Until next time, keep coding, keep learning, and as always, stay awesome.